Hey everybody, welcome to my channel. I'm Hannah. Today we are going to be doing some C++ linked list manipulation. So in my last video, I showed you how to implement a linked list in C++, and now we're going to write some functions to manipulate that list. So this is what we wrote last time. Oops. And this time I'm going to stick some functions right before main. So the first one I'm going to start off with is one to display the list, and I'm just going to call it print list. And we're going to take a node and we'll just call it n. And so while, n is not null because we don't want to print an empty list, we are going to output n data and a space. Oops, almost forgot to set my n to next because you want to move it along the line. This is what that's going to look like. I'm going to print it from the beginning of the list ahead. So then we have everything in my list, 1, 2, 3, 4. So we are going to write the push function, which adds a new element to the beginning of the list. So we'll call it push. When you see 2 stars like that, 2 asterisks, that means it's a pointer to a pointer. A head reference and the new data that you want. So let's create our new node. New element. Have to allocate this memory. Just make it the size of the node. Oops. And now let's set our data for the brand new element to be the entered data. And let's set our next pointer to the current head, of the list, and that needs to be a pointer. And then let's set that pointer to the new element. Okay, so that is basically the push function that is already defined in C++, so don't worry, you don't have to define this every time you use it, but I just want to show you how it's used in case you're asked. So this is how you write it out. Oh, no it isn't. I forgot. Okay, so this is what we got. Oops, which is exactly what we should have gotten. I think I'm going to put these on new lines just so that they're easier to see. Okay, I switched it up a little bit. So now at the beginning it says your current list and then they're on separate lines. We went in and we used push to add a 0 at the beginning, and here is our 0. So it worked as we wanted it to. Next function we are going to do is push back, which is going to add to the end of a list. Call it push back. Takes the same arguments as push. So again, we want to allocate some memory for the new node. Okay, now this time, I'm also going to create a node for the last element, which is now going to point at the head. So our new element, data, equals the new data that we entered. The next pointer points to null because it is the tail end of our list. And we are going to say while we are not at the end of the list, basically, while there's still a next, last is going to be next. So we're just going to go down the line, basically, until we find the last element. And then the last next we set to the new element. Okay, so now I'll show you how that looks. Push back, ahead, and let's add 5, just because we're keeping with that sort of trend. So there, just like we wanted it to, it added 5 at the end of the list. So this next function I'm going to write will insert an element after a specific location. So you pick a node and this will insert it after that node. So this one I'm just going to call insert after. Node. And this is just one asterisk here. Oh, no. We need, so I'm going to write previous node. Do not confuse that with previous pointer. Okay. It's not a pointer in the sense of like a doubly linked list where there's a pointer, a link to the next and link to the previous. It's not a link. New data. And I'm just going to copy this allocation and paste it in there. Okay, so we are setting our new element data to be the new data, and we're setting our next. Now this might be a little confusing, but basically we're taking the new element's next and we're setting it to the current previous node's next. Feel free to go over that a couple times until it makes sense if it doesn't. And then we have to set the previous node's next to something. So that will be set to the new data. No, I lied. New element. All right, so that is your insert after code. We're gonna put it after the third and we're just gonna enter the number 13. So it went in after the element called third, which is now in our list, actually our fourth element, because we added that 0. So now that we know how to insert after a specific element, we can also delete after a specific element. So we just need to find the previous node. That's all we need to know. So let's create a temporary node. This one can be a little bit difficult to follow. I'll try to explain it as best I can. So we set the temporary node to, previous node's current next. Because the previous node's current next is the node that we're trying to get rid of. So then let's set our previous node's new next to, okay, so temp is the current node you want to delete. So you want to set your previous node's next to the element you want to delete next. So that would be temp next. And then you want to completely get rid of the temporary node. So that is how you delete. Now I'll show you how that works. I'm gonna delete what I just created. that 13. So now it will just be 0 through 5. Yep. So now we just have 0 through 5. Now the last function I'm going to show you is how to delete the entire list. So we're just going to call this delete list. And so you need a pointer to the pointer to the head. So let's make one and we will call it current. And this is going to point at the head of your list. And then let's also create one called next. And then basically while current is not null, so while there's still elements in the list basically, we will set next equal to current's next. And then we're going to use the free function. And what this does is it deallocates the memory. And then let's set current equal to the next one. Oh, and before we close this out, let's set head reference equal to null. So then I will, oh, and then let's like put a little message in there like, hey, your list is gone now. Okay, and then I'll show you what that looks like. Delete list. What do I point at? Just the head. I don't know why I keep capitalizing the D's. It says, hey, your list is gone now. So that works as we wanted it to. So I just realized that because of the way that I have my Windows set up on my software, on my recording software, you guys might not have been able to see the bottom of the list. So, or the bottom of the compiler or executor or whatever you want to call it. Anyway, so I wanted to show you, okay, so, because I'm dumb. So the first one is, that's your current list, and then when you push a 0, and then when you push back a 5, and then when you insert after, here's the 13. And here's when you delete after. I inserted after third and deleted after third. So there's the 13 when I inserted after. There's the 13 when I deleted after. And then here is where I used the function delete list. And I put that little code in there. Hey, your list is gone now. These are just a couple of ways you can manipulate a linked list. Software engineer interviewers will ask about this kind of stuff all the time. Even though there are libraries with pretty much all these functions built in, they just want to make sure that you really know what it does. Just want to make sure you really, really understand how memory is being allocated, how the pointers work. Thank you guys so much for watching, and I'll see you next time. Bye!